Exactly. I'll probably do it on the first few. If restrictions are asked for in any fraction, you're always just going to set the denominator equal 0 before simplifying. So, same idea. Alright, so before we get into any of the actual new knowledge, we're just going to practice adding and subtracting some fractions just to make sure you remember all the rules. So can I add these two fractions together?
Yes.
Because they have a
Common denominator.
So it's going to be 4/7. Perfect. Can I subtract these two right here?
No.
No, because they don't have a
Common denominator.
Good, so we have to find a common denominator. So a common denominator is always found by finding something called the LCD, which is the least common denominator. That'll be the smallest number that both of your numbers will divide evenly into, okay? So in this case, what would that number be? 12, and then of course they both have an x, so it's going to end up being 12x. Now what you're going to do is you're going to multiply this fraction, top and bottom, by 4, and the other one's going to get multiplied by 3, and that will then allow us to have that same denominator. So when we do that, whatever we get in the numerator is what's going to go up top, okay? So that's going to be 4 minus what?
15.
15, which comes out to be
Negative.
-11. Perfect. With that common denominator. All right, you guys seem to get this part pretty good so far. So in this case, there's going to be a numerical and a variable common, or LCD. So what would be the numerical LCD here? 4, because they both evenly go into 4. And then we need to take whatever factors they have in common, which is the x, and then anything they don't have in common, which would be the y, right? To get that common denominator. So what would I have to multiply the first fraction by to get it to become that? 2y. Does the second fraction have to be multiplied by anything? No, because it's already where we need it to be. So it's going to become 14y minus 5. So that's basic fraction expression evaluation. So now we're going to use these skills to do more complex situations, okay? So this one here. We want to add these two fractions together. So our goal is to find that common denominator. So what would be the numerical LCD here? 10, because they both evenly go into 10. Now when we're dealing with variables, here's what you're going to do. Any variables they have in common, you're going to take the higher of that power. Because this one, basically the higher of that power is going to be a to the third. So whatever one has the higher is going to be the part of the common denominator. And then it's going to be b to the second. Perfect, squared. So if we had any variables that one had that the other didn't, we'd also have to include that as well. Alright, perfect. So what are we going to have to multiply this first fraction by? 2, just 2, yep. What about the second one? A squared b. Good. So remember, keep in mind, this denominator currently only has one a. We need it to have 3 a's, so I got to put 2 more in. This denominator only has one b. I need it to have 2 b's. So that's the reason I have to do that. So this is going to be 8 plus 9a squared bc. So if you put the letters in a different order, that's still correct. I just do it in alphabetical to keep it like streamlined, but you don't have to necessarily do that. So can I combine the numerators together? No, because they're not what? Not like terms. So just a reminder, if you were ever asked what the restrictions were here of the original, of course you look at it, a cannot be 0 and b can also not be. So just a reminder about restrictions in case they ever come up, that is how you would do them. We practiced a ton with that though, so you should be pretty good with it. Alright, this one here, we find our denominator. So what would be the numerical LCD here? 8. And then we take x to the, and then y to the, good. So the highest power of every variable is what you take from the denominator. So what do we have to multiply the first one by to get it to where we need it to be here? 4. Perfect. 4y squared. Okay, 4y squared. Alright. And what about the second one? X squared, perfect. So, my top is going to become 12y cubed, right? Minus 5x squared z. Yes?
I have a question, like, how do you get to the denominator? Like, what's the rest of it?
You find the largest number the smallest number they both divide into. So 8 would be the smallest number that both 2 and 8 go into evenly.
Okay.
And then as for the variables, you always take whatever the higher power, whichever one has the higher power on that variable is what you make the common denominator.
Okay.
Any other questions? Okay. Next one. So on this one, you might be looking at these and thinking they have an x in common, but that doesn't count because these are separate factors, right? So each one of these factors has no common factors, of course, because they're two separate factors. So when you don't have any factors in common, your least common denominator is just going to be the product of whatever those two denominators are. Okay, sometimes the LCD is just the product of those two things. And then, of course, when you're dealing with this type of situation, you have to multiply each fraction by the opposite's denominator to get it to have that common denominator. So the first one's going to be multiplied by x plus 2, and the other one's going to be multiplied by x minus 1. So when I write that out, it's going to be x times x plus 2 plus 2 times x minus 1. Now, whenever you end up with a addition or subtraction sign outside of the parentheses, you know you have to simplify this by multiplying it all out and combining like terms. So, what's this going to become? X squared plus 2x, and then this one is 2x minus 2. And that whole thing is over that original common denominator. Now, you want to simplify, combine like terms anywhere possible. So, of course, we have those two to combine up top. And then what you want to check is whatever you ended up with as a result, see if it factors again. In this case, does everybody see why that doesn't factor again? Yeah, there's no factors of -2 that add up to 4, so we just leave it the way it is. But if it does factor, you do want to factor it, because sometimes that does happen. All right, any questions about that?
What would the restrictions be?
1 and -2. All right. So, we're going to deal with more that have the polynomials in them, okay, because that's a lot of what we deal with in rational functions. So first thing you always want to do when you're adding two fractions together that are all polynomial is whatever can be factored needs to be factored. So as you can see, this one, I can't do anything to factor that. The numerator, I could factor out a 2 and get a fraction, but we don't want to do that, so that really doesn't factor. But what about the denominator? What does it factor into? X minus 2 and x minus 1. So does everybody see how we factor that denominator? Now that we did, what you're going to notice is, do you see how they have a factor in common? So we know whatever factor they have in common is going to be included in the LCD, the least common denominator. Now, when you have a factor in common, you only need to count that once in the LCD. Any factor that one has that the other doesn't is also going to be in the LCD. Okay, so we know it's going to be the product of those two things as my LCD. Now we have to figure out what we have to multiply each of these fractions by to get it to have that denominator. So what would we have to multiply the first fraction by?
X minus 2.
X minus 2. So of course that's just going to be x times x minus 2. And then do we have to multiply the second fraction by anything? No, because it already has the denominator we need, right? Does everybody see why we don't have to? So now what we're going to do is simplify the top. So I'm just going to wait to write in the denominator for now. You'll see why. What's going to happen with those terms in the middle? They cancel out, and when I do cancel them out, what do you notice this is right here?
Differences.
Doesn't this factor again into what?
X plus
X plus 1 and X minus 1.
X minus 1. And that's all over the denominator, of course, because we just didn't write it in. And now, what do you notice we can do again? Cancel. So my final answer is x plus 1 over x minus 1. And that's all we can do with that. Make sense? Perfect. Alright, we have letter B. So first thing we're going to do is just factor everything. Bottom you can take out an x. And you should end up with something that looks like this. Everybody get to that point. This kind of looks like a C. Let me rewrite it. It's a little wonky. There we go. Alright, so once we get here, we're going to find that LCD. Now we know in an LCD, whatever factors they have in common are always going to be included in that LCD. Okay? What we're also going to include in the LCD is any factors they don't have in common. So the 2 is going to be included, and what else? The x. So ultimately, that's going to be the 2x that goes right here in front. And then what we're going to have to do is we're going to have to multiply each of these individual fractions by whatever we need to multiply them by to get us to that LCD. So, what are we going to have to multiply the top and bottom of this fraction by? 2. What about the second one? X. And when you multiply a binomial times a monomial, I like to put the monomial out front, okay? It's just easier to work with. So just keep that in mind as you're going through the process here. And don't forget, if it's subtraction, just make sure you put subtraction, don't confuse it with addition. So we get here, and now we're going to have to simplify that numerator to get everything worked out. We end up with 2x plus 4 minus x squared minus 2x. And I'm going to try to simplify this before I write the denominator in. What's going to happen with the 2x's? What are we left with? Difference of squares, right? So how can I factor this? 2 minus x and 2 plus x. So a lot of people get confused when the difference of squares has the number first. It doesn't matter if the number or variable is first. Difference of squares just means difference of 2 perfect squares. They could be numbers, they could be variables. Whatever one comes first is the one you write first. Okay, square root of the first minus the square root of the second. So any questions about how we got here? Now, can we cancel anything out? Good. We can't cancel anything out as is, but we can do a loophole, right? We can cancel these out if we put in a -1. So we end up with something like this. Now, your test, I believe, I'm not sure if the test is, but I know your quiz is multiple choice, a lot of these. So just be aware, this might be distributed out and written like this. Okay, you have to be able to recognize things in different formats because it may be distributed out like that. All right? Any questions about that? Okay. Next. Okay. So this is what we call a complex fraction in math. It's basically an operation with fractions over another operation with fractions. So the best way to handle these is to just deal with them each separately. We're going to simplify this like it's its own problem, get a fraction, and then we're going to simplify the bottom, and then we're going to divide them. So it's like combining what we learned today and yesterday all together. Okay? So, step 1 is let's add those numerators. What do you notice about the numerators the way they are right now?
Same denominator.
They have the same denominator, right? And that denominator we can just is the same, so we can just add the tops, right? Which becomes what? 3 over 3x, which we're going to simplify in a second, but we'll get there. What do you notice about the denominators? Do they have the same? No. What can we do to make them have the same denominator? Multiply the first one by 2, right? So this becomes 2 plus 1, which is 3. So when I want to add those together, find a common denominator, and it becomes 3 over 4x. Everybody with me so far? So this top reduces to 1 over x, because the 3's cancel, right? Over 3 over 4x. Now this is similar to something we talked about yesterday. When we want to divide two fractions, we do what? Keep, change. That's the division is turning into multiplication. And then we're going to flip that second fraction. And then we can just multiply across. And we get 4/3 as our final answer. Do you have any questions about that? Easy. All right. Letter B. So letter B is a bit lengthy, but I know we can all do it. It's just going to take a little time. So with letter B, as you can see, the numerator does not have the same denominator. So our denominator is going to be the product of the two original denominators. Okay? That means I'm going to have to multiply the first one by x plus 1 and the second one by x. Okay? So that's going to become x minus 2 times x plus 1 plus 2x. And that's what we have so far. I have to make that line a little longer. So as for our denominator, we're going to simplify that later. We'll get to it in a bit. For the denominator, it's going to be the same idea. You're going to notice the denominators don't have any common factors. So we're going to just take the product of those denominators and then multiply each of the numerators by the opposite denominator, which will, of course, give us a common denominator. Everything's worked out. So this is 3 times x plus 1 minus 1 times x minus 1, like that. So now that we're at the stage that we're at, we can convert this division problem into a multiplication problem. Now, you can write it out as multiplication right away, but what I'm going to do is I'm going to partially simplify as I do it to save some room. So I can see that this top is going to FOIL out, right? I'm going to have to do FOIL on that. So that's going to become x squared, first, outer, inner, and last, plus the 2x that was already there. And I know that's all over x times x plus 1. And then this one here, remember, we're changing it to multiplication, and then we're going to flip this fraction as we do it. This one is going to be distributed. This is our new denominator. And I'm going to distribute here as well. So we end up with something like this. Now we're going to just cancel out anything that we can cancel out. So these can cancel out. And when we do cancel those out, we end up with the numerator x squared plus x minus 2. Does that look like something that can be factored? Yeah, what does it factor into? Positive 2 and negative 1, right? Does everybody see how we factor that?
Yeah.
Now we have that original denominator. Yeah, what's up?
What'd you just factor?
This right here. It's just like what the top was without... Exactly, yeah. I just try to do it without having to rewrite everything every step. So then down here, what you're going to notice is for the bottom, this right here, if you simplify it, it becomes 2x plus 4, right? Does everybody see that? What can I factor out of 2x plus 4? A 2. And now we get here. Now we're at the stage where we can start canceling some stuff out. Sorry. So what can I cancel out here? The x plus 2's cancel. The x plus 1's. Did the x minus 1's cancel?
No.
No, because they're both on the same. They're both on the top. So I can rewrite them as x plus 1 squared with my remaining denominator of 2x. And that's our final answer. Alright, I'll go ahead and hand out your homework.